Hello. So yesterday we have done. Good morning. Uh, Yesterday we have done one problem. We'll do second problem. Then we'll move to the next topic. Okay. Right. I already shared the notes to one of your uh, friend, and if any CR or leads are there, I will send the notes to them. Okay. Right. Uh, Yesterday and today. That is second unit. Okay. Right. So write down second one. A wave connected armature winding has 19 slots with 44 conductors per slot. If the flux per pole is 0.066 Webers and the number of poles is 8, calculate the speed at which the generator should run to give 564 volts. Calculate speed if the armature is lap connected. So here we have to calculate speed. Okay. So 19 slots with 44 conductors, flux per pole, number of poles 8, and a lap connected, this one. So these are the underlined are the parameters given in the question. So write down that parameters as the given data. Okay, underlined quantities. So we have to get here Z. Z is equal to total number of conductors. We are having one formula. What is that formula? Total number of conductors, that is Z is equal to total number of slots into conductors per slot. Okay. So here how many slots are there? 19 slots, and each slot how many conductors are available? 44. So that is nothing but 836 conductors are available. Okay. Right, is given. Okay, this pi is given. Pi is 0.066 Webers. And then the number of poles P is 8. Speed at which, calculate speed, that is N is equal to how much? To give Eg is given Eg 564 volts. Now what is the value of N? Okay, for this we require A. A is given. A is lap connected, lap. See a lap, A is equal to P. Like this you remember. Lap connected, what is the value of A? A is equal to P. You can easily remember. Remaining wave, wave means A value is 2. Wave connected means A value is equal to 2. Lap connected means A value is equal to P. In the name itself it is written. Lap, L-A-P, lap. Lap connected. What is the value of A? A is equal to P. You can easily remember by the name. A is equal to P. Okay. So everything is available. Okay. What is the formula? Eg is equal to pi Z N P by 60 A. Everything is available. Pi is available. Z is available. Eg is available. We need N. P is available. Okay, A is available. A is how much? P. P is nothing but 8. A is also 8. Substitute. Write down the formula. Substitute in the question. In the formula. Okay. You will get the answer at the speed as. So here we solved for wave winding as well as lap winding. So in exam is asked about only lap winding. So second one, this. Okay, so this part is given in the question. So n is equal to 613. If you want to calculate speed at a wave winding also, you can calculate. Okay, so n is equal to only substitution in the formula. Ej is equal to pi znp by 60a. So already Eg is given, n you have to follow, right? You have to determine. Okay, here also same. Okay, so here for the generator you need to find only one formula, that is EMF generated in the DC generator is equal to Eg is equal to pi znp by 60a. So please be mind that every parameter is available in the question. Eg is equal to pi znp by 60a. Just you have to pick the parameter from the given question. Pick the parameter from the given question. For example, if you are unable to solve the question, what you have to do? At least you write down the given data. At least you are unable to remember the problem. That means formula. EG formula you are unable to remember. Okay, then but you write down what are the parameters available here. What are the parameters? Like this you write down. This one you will get 1 mark. This one for writing of this you will get 1 mark. For even a formula 1 mark. Otherwise this 3 marks. Okay. After this substitution, for substitution you will get remaining 4 marks for getting correct answer and substitution. Simple. Okay. So don't if you are unable to solve this problem, don't leave the problem. Write down at least something. Pick the data from the question. Okay, EG value. Okay. Is a question. Is a given data, wave connected, we have done the problem. Then for lap winding, in the question it is our lap connected is given. So A is equal to 6. Substitute in the formula. Okay, A is equal to 6 only. No, 8 kada. So you have done mistake. A is equal to 6. Otherwise you make the change in the question only. No, make the change in the question. P is equal to 6 you write down. Here you write down P is equal to 6. Okay. P is equal to, you make a change of 6. Remaining everything is okay. Small human error. Okay. So kindly remember this. Now అందులో తక్కువ చేయండి. హలో 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 yes. So we will move to the next topic, that is DC motor. What is mean by DC motor, or what is mean by, what is the definition of DC motor? DC motor, simple. Okay, so motor is nothing but it is a device or it is a machine which will convert electrical energy into mechanical energy. That is the definition of motor. So we are using DC supply, that's why we can call it as a DC motor. Okay, so what is the principle of this one? What is the principle of DC motor? What is the principle of DC motor? So here let us consider లేదు చెప్పలేదు నిన్న మధ్యాహ్నం వాళ్ళు కాదు కదండి, పొద్దున వాళ్ళు కదా మీరు. జనరేటర్ అవును కరెక్టే, మధ్యాహ్నం వాళ్ళకి అయిపోయింది, మధ్యాహ్నం వాళ్ళకి ట్రాన్స్ఫార్మర్ వాళ్ళకి అయింది. ఓకే, so the principle is here, principle of DC motor. Actually DC generator, DC motor both are equal in the construction. There is no difference between them. You can use a DC generator as a DC motor, DC motor as a DC generator. With respect to construction is concerned, both are equal, there is no difference between them. Okay, DC generator, what are the available different parts are available in the DC generator, same parts are available in the DC motor. Okay, there is no difference between them. Okay, so but only the difference is DC generator means input is mechanical, output is electrical. We are rotating, we are getting electrical energy, that is for generator. Here for motor we are giving electrical supply, output is start rotating, like our ceiling fan, whenever we are switching on it is start rotating. So how it is rotating, on what principle? Simple. See here, I think you know the conductor, this cross symbol indicates that current is going inside, dot symbol is indicates that current is outing or outgoing from the board. One is like this, one is inside, other one is so this is inside. So we are given cross symbol, it is outward, we are given dot. Okay, so why? Because it is look like this. So we are placing this one is like this. So it is front view, that's why you are able to see only these two. Okay, right, here one more. So what happens, actually it's not a single conductor we are placing group of conductors. Okay, simple. Here this conductor carries the current, why? Because we are switching on, what happens, total winding, okay, current will pass. Okay, we are switching, current will pass to the winding. Okay, so current carrying conductor placed in a magnetic field, that is the statement. Okay, current carrying conductor placed in the magnetic field experience a force. It start rotating, so it experience a force. like this. Here another conductor is there, it experiences force. It is another conductor is there, it experiences a force. Another conductor is there. So here then experience a force like this. It is start rotating, these conductors are start rotating. So total how many conductors are available, that cumulative force, okay, like this now. Start rotating. So cumulative force start rotating like this. Okay. So the principle is a current carrying conductor placed in a magnetic field experience a force. Okay. It is start rotating. This conductor is there, because of it is in the magnetic field, it start like this. Other conductor is there, it start moving. Other conductor is there like this. So cumulatively for all conductors, every conductor start like this, moving, 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 moving. So cumulatively it start rotating. That is the principle of a DC motor. Okay, construction is equal, there is no difference between them. Okay. Okay, so this is about DC generator or DC motor. DC motor construction means DC generator construction, there is no different. If in exam DC generator construction means, yesterday we studied how many parts are there, stator, rotor. Okay, DC generator construction, same construction DC motor, there is no difference between. Explain the construction of DC motor means you have to explain the construction of DC generator only, there is no difference. Okay. How can we separate main parts for DC generator? What are the parts we are having? One is stator, second one is rotor. In stator, what are the different parts we are having? Stator. What is the other name? Stator, yoke. What is the function? What is the function of that yoke? It carries the, where it houses the poles in the yoke. Okay. Then pole shoe and winding. Pole will generate the flux. Pole shoe which will equally distribute flux to the rotor conductors. Winding. Okay, we are converting that pole iron piece into magnets. So okay, that is the use of copper. That winding. Winding is made up of copper, pole is made up of cast iron, pole shoe is made up of cast iron, yoke is made up of cast iron. So you have to write down its parts, okay, and what is the use and its material. Then rotor, stator is over, rotor. So rotor consisting of rotor slots and rotor conductors. Then commutator brushes. Okay, why we require slots? Will keep the conductors in the slots. Okay, why we require brushes? Why we require brushes? Why we require brushes? Why we require commutator? Why we require conductors in the rotors? In the conductor only EMF will be generated. Okay. DC generator, a conductor rotates in the magnetic field and EMF will induced. That is DC generator principle. A conductor rotates in the magnetic field and EMF induced in the conductor. So okay, why we require this conductor? In order to generate EMF we require conductor. Okay, right. Why we require field? Why we require field? What is the use of field? Why we require field? ఏంటమ్మా నేను చెప్పాను కదా. How can we get field? How can we get field? By using two magnets. That is, two magnets are permanent magnets, or we are making iron piece as the magnets. How we are making iron piece as the magnets? By wounding the copper wire around the cast iron. Okay, if we wound clockwise, it is north pole. If we wound anti-clockwise, this will called as a south pole. Like this, north pole, south pole. So in the field only we have to keep the conductor. We will start rotating. Then EMF is generating. Exactly same parts for the DC motor. But here the difference is already conductor carries the current. A current carrying conductor placed in the magnetic field experience a force. So whenever I am switching on, it start rotating, cumulatively rotating. Same principle, generator and motor, exactly the input and output is different. Okay, construction is same. There is no derivation, there is no formulas for the motor. Okay, only now for the DC generator is concerned. Okay, DC generator main important questions are: first one, explain the principle of operation of DC generator. Second one, explain the construction of DC generator. Okay, or explain the construction of DC motor. Both are equal. Generator and motor means you have to explain same thing. There is no difference. Construction of DC generator is equal to construction of DC motor. So you study one time, you can get the two different questions. Okay, right. Then derive the EMF equation of the DC generator and problems. How many questions we are having with respect to DC generator, DC motor? DC motor, explain the principle of operation of DC motor. So maximum you will get 4 or 5 questions. Okay, now we'll move to the transformer. We'll move to the transformer. Okay, next topic is transformer. Okay, transformer. So transformer, did you see in transformer? So the main use of the transformer, simply I can say, okay, in daily life we are using charger. Daily life we are using charger. So what is the input? We are giving input here, 230. For the charger, daily life for charging of our mobile phone we are using charger. What is the input? 230. What is the output? 230 AC it is. Charger output, the charger pin is there na. What is the output there? 9 volts DC. 9 volts DC. So we are studying now transformer. Actually where we have to use this transformer, what is the main use, you have to know. That's why I am explaining this. What is meant by transformer I will explain, but what is the use of this transformer, where we can use in daily life? Yes, it is available in everywhere. Okay, in this also it is transformer is available. Okay, in the charger also transformer is available. In our colonies also very big transformer is also available. In our TV transformer is available. Okay, in every place transformer is available. What is the function, what it will do actually, you have to know. Transformer, what it will do. Motor means what it will do. Ceiling fan, motor means ceiling fan, it is AC motor. We require air, so we are using, switching on. So applications are very important where we have to use. Okay, simply you can say transformer where we can use, why we have to use. So actually here see how much, 230 volts AC. Actually it is input. Our charger is like this. Okay, it is input, and here one wire is there, and we are keeping this one to our mobile phone. Okay, here it is, input is 230 AC. Wire is having here 9 volts DC. Then who will doing this 230 to 9? It is DC. So first here there are two parts are there in this. In this there are two parts are there. One is transformer, one is rectifier. Okay, in between this, okay, one is transformer plus rectifier. So transformer, what it will do, main function of the transformer. For example, I am having 230 volts AC. It is a voltage. So input it is. So input means V1. Output of the transformer 9 volts AC. V2. See what happens? What it is changing? Voltage level is changing. Yes? So that is the main function of the transformer. Whenever you require to change the voltage level in the circuit, wherever you require. Why? Because your mobile phone works with 9 volts only. It is not works with 230. Okay, it works with only 9 volts voltage. It not works with 230 voltage. It works with only 9 volts. Okay, in your TV, you know, in your TV is there na TV. Nowadays very big TV, 55 inches TV, 45 inches TV are there. For that, in order to deliver that screen, that is called LCD screen or LED screen. There are two types. One is liquid crystal display. Other one is LED. Which one you are having? That is up to you. You have to know. Okay. One is LCD, liquid crystal display. Other one is light emitting diode. Okay. So better example, this one, the smart board. Okay. Which one this one? Which one this one? It is LED. It is LED screen, this one. That means it is a diode. How big it is? Diode. Diode, how big is it? Big it is? It is a diode. Display is there, na? This is called LED, light emitting diode. It is a diode where light emits. How much voltage it require now? How much voltage it require? Tell me. How much voltage it requires? It requires 2000 DC voltage. It requires 2000 DC voltage, not AC. Who will do then? Transformer will level up the voltage. 230 voltage then for this display. Voltage V1 is how much? 230 volts. I require how much? V1, V2. V2 is 2000. It is AC only. It is AC. Then there is a circuit is called rectifier, which will convert AC to DC. This AC is converted to DC 2000 by using rectifier. That is the function of rectifier. We are not talking about rectifier, but transformer. What it will do? See, 230 volts is converted to 2000 voltage. Okay, 230 volts is leveling up to 2000 voltage. 230 volts is leveling down the 9 voltage. That is the function of the transformer. Input voltage 230 only. Output what it will do? I have shown two types. In your TV, in your household, the voltage level increases. Why? Because this display requires more voltage. 230 voltage is not enough. Okay, it requires more voltage. 2000 voltage, 1000 voltage, depending upon your that area, 45 inch, 55 inch, okay, 20 inch, 18 inch, like this for your computer, personal computer display. So it requires only 500 voltage. Okay. 15 inch, like this is then 18 inch. So depending upon the light emitting diode area, we require voltage. So do you understand where we have to use the transformer? So wherever you require to change the voltage level, okay, change the voltage level of the in the circuits, wherever you require. Okay. So in colonies we will see transformer. In colonies you seen very big transformer, that is called a distribution transformer. Distribution transformer. Okay. So distribution transformer, what it will do? It will change 11,000 voltage to 230 voltage level. To 11,000 input of the transformer. Output is 230. And then 230 it is going to your house. That is called a service wire, where we are having two terminals, red and black. Okay, so what is the input of this transformer then? It is not 230. Transformer input is not equal to transformer output, voltage output. So 11,000 voltage is converted to 230 voltage. So leveling down there. Okay. So that is the main usage of transformer. Now how it is doing actually? How the voltage is changing? That is, we have to know the principle. How it is changing the level of voltage. 230 voltage, how it is converting to 9 voltage? 230 voltage, how it is changing to 2000 voltage? How it is leveling up? What parameter it depends? Okay, you answer that question now, not now, after completion. How it is changing the leveling, the which parameter it depends? Okay, this question, please keep in mind that what is the parameter, or on which parameter of the transformer this change of voltage is taking place. You answer this one after knowing the formula. Okay, you have to tell that one after completion of this topic. You have to tell that answer. What is the question? On which parameter the voltage changing? 230 is changing 9 voltage. On which parameter this change of level of voltage is depending? You have to answer this question after completion of this transformer topic. Okay, right. Which will change AC to DC. We require DC. Here we require DC. Transformer will change the level of voltage. Only change of level of voltage. 230 voltage AC to 9 voltage AC. This 9 voltage AC converted to 9 voltage DC by using rectifier. So rectifier is a circuit which will convert AC to DC. Okay. For the syllabus you are having, I don't know. Okay. So rectifier is a circuit which will change the AC to DC, which consisting of bridge rectifier, will say half wave rectifier, full wave rectifier we are having. Okay. So right. Now how the transformer is look like, we'll see. Okay. So first one, on what principle transformer works? So transformer works with the, actually there are two principles are there. One is transformer works with the principle of same Faraday's laws of electromagnetic induction, and other one is Faraday's laws of electromagnetic mutual induction or mutual induction. Okay. So Faraday's laws of one is electrical induction, second one is electrical mutual induction. Okay. Electrical induction, electrical mutual induction, Faraday's laws of, both laws are available for the, okay, transformer. Okay, right. So transformer is, how it is? Okay, transformer. So I am taking one iron piece. It is in the form of square. For simplicity, it is a core which the area is square. It is a iron piece. Okay. Now what I am doing now, for this iron piece, total is iron piece, I am wounding the winding around this. So it is called core. Okay, core is made up of cast iron. Okay, right. So I am wounding the winding here. Okay, so here it is AC supply, which is having the frequency. AC supply which is having the frequency. What I am doing? AC supply, I am wounding this one. So charger input, charger is there na, charger. Your charger input is only, you will see this one. So inside the charger this one is there. One iron core is there, and for iron core, okay, iron core we are wounding this one here like this. Okay, iron core is there like this, we will wound. So one is okay, positive terminal phase, or one is neutral, or one is see current is going inside and wounding and current is coming out, which form the closed circuit. Yes, which form the closed circuit. So here one of the winding. Next, here also one I am wounding the winding. This is output. This is transformer output. In your charger, this two terminal is given to the rectified circuit. Okay. In the charger, these two terminals output. This is called output. This is called input. This is output. Okay. So in your charger, this is the input. Whatever you see, the two terminals are there now. The two terminals are this one. This one here you are having two terminals. Okay. Transformer output are there now. These two terminals are given to the rectified circuit. Rectified circuit. Okay. Right. So here see, this is load. Load. So input and output. Okay. So now here I am wounding here. Wounding. How many turns I am wounding? Let us say because of it is the input, so I am wounding as number of turns are N1. Number of turns. How many turns? So N1 is the number of turns, primary turns. N2. Number of secondary turns. You can say it is a primary, it is a secondary. So primary winding. It is a secondary winding. So what is the definition of primary winding? How you are saying it is a primary? Primary is nothing but inputs. Input supply. The winding which is connected to the input supply is known as primary winding. The winding which is connected to the output. The winding which is connected to the output, or the winding which is connected to the load, is known as secondary winding. So in the transformer there may exist a primary winding as well as secondary winding. The other name you can call it as input winding, output winding. Okay, that is up to you which word you have to use. Two windings are available. One is input winding, one is output winding. One is primary winding, one is secondary winding. Okay, so now with respect to this, how many windings are there now? How many windings are there? How many windings are there? How many windings are there? Two windings are there. What are they? Primary winding and secondary winding. Okay. So this winding I wounded as the number of turns. How many turns? Maybe N1 turns. Maybe N2 turns. So where N1 is the, 1 indicates the primary, 2 indicates the secondary. Okay. So it is, what is the voltage? Let us say it is V1. Applied voltage is V1. All primary nomenclature is 1. What is the current here? I1. The current flowing in the primary winding is I1. The applied voltage is V1. Secondary. Here current will flow I2. What is the voltage? V2. What is the turns? N2. So secondary means you need give the nomenclature as the 2. Primary means you have to give the nomenclature as 1. Okay. So 1, V1, I1, N1. V2, N2, I2. So these are the nomenclature. How many windings are there? 2 windings are there. So winding is made up of copper. Winding is made up of copper. Simply you can say in general transformer consisting of 2 parts. Transformer consisting of 2 parts. One is called core. Second one is called winding. Winding or windings? Windings. Simple. with respect to construction of transformer is concerned, there are two parts are there for any transformer. Okay, two parts are there in the transformer. These are the main parts. Okay, one is called core, second one is called winding. Okay, what is the function of core? What is the function of winding? Which material you are using? For a core you are using cast iron. Okay, for the winding you are using copper. But what is the function? Okay, if you know the principle, then you are able to answer that core and winding function. Okay, simply. Okay, now I am explaining the principle of mutual induction, Faraday's laws of mutual induction. Okay, now by observing this, okay, is there any connection between primary to secondary? Connection, circuit connection is there from primary to secondary. Circuit connection, copper wire is going directly to the input to the output. For this, copper wire is directly connecting to input to output in this circuit. Connecting? Huh? No. So primary is this one only, connected here. Secondary is this one only. Is there any connection between primary and secondary? There is no connection between primary and secondary. There is no wire. Generally, what is the meaning? In the conductor, current will flow from here to here. High potential to low potential current will flow. Okay, one place to other place in the circuit, in the interconnection, one place to other place current will flow. Here, there is no connection here. This copper wire is not connected to this copper wire. There is no direct connection between primary winding, secondary winding, or primary circuit, secondary circuit. There is no circuit connection in between two. Direct connection is not there. That's why we are saying mutual induction. Principle of mutual induction. Transformer works with the principle of mutual induction. What is that? I will explain now. Okay, before that, see. Okay, primary winding, input winding, we are connected now. Okay. So, principle of how it is working, how the voltage level is changing from input to output, we will see now. Okay, right. So now here whenever a AC supply is connected to the primary winding, okay, AC supply, AC voltage I am applying. Whenever AC supply is applied to the primary winding of the transformer, what happens? Okay, so the circuit is closed. Then what happens? Whenever I am connecting a supply to the primary winding, what happens? A current of I flows through the winding. Okay, it leaving from here, it is flowing towards the winding. Okay, and then it is returning to the here negative supply. So a current of I is flowing in the circuit. Okay, so here what is available here? It is core, iron core, and we are wounding the number of turns as the N1 turns. How many turns? N1 turns. How many turns are available? N1 turns. Okay, so these turns are available. We are wounding around the cast iron piece. Okay, now whenever we are applying AC supply, because of the closed circuit of the winding, a current of I is flowing. So this I is also AC. Okay, so because of woundness around the iron piece. Okay, we wounded around the iron piece, not insulator, not wood. It is a cast iron piece. Okay, whenever a current carrying conductor is wounded around the iron piece, okay, a flux, alternating flux is established in this iron core. Flux will be established in the iron core. In the iron core, what happens? Flux will be established. Okay, so alternating voltage, alternating current. Now it is a alternating flux. So whenever I am applying the alternating voltage, because of the circuit is closedness, so alternating current will flow. So this alternating current will flow in the winding, okay, and this winding is wounded around the iron piece, okay. So a flux, alternating flux means not a direct flux, direct current flux. A alternating flux is established in the core. Okay, how it will flow? Because of we wounded clockwise direction, this flux will flow like this. Flux will establish. You cannot see the flux, okay? You cannot see the flux. Okay, is established in the core. What happens actually? Alternating flux establishing. Alternating flux means, what the meaning? Time is changing. Alternating flux. Y-axis, what is the value? Flux. So flux is establishing like this. So voltage is AC, voltage is alternating, current is alternating, and flux also alternating. Flux also changing with respect to time, positive value, negative value. Yes. So now this, whenever a flux is set up in the coil, what happens? This alternating flux will induce an EMF in the winding. Okay, so now there is a EMF established across the winding, which is known as E. Okay, an EMF is induced in the winding, that is known as E. Okay, an EMF is induced because of this d pi by dt. How the pi is changing with respect to time? So d pi by dt, d pi by dt, not df, d pi by dt. So this alternating flux is capable of induce an EMF in the primary winding. Already voltage is available. Again EMF is inducing here. Okay, right. Now this flux, what will happen? This flux will flow like this. So it clockwise flux will flow. Now you tell me, now this flux is changing with respect to time. Because of this circuit, flux is established, and this flux is alternating flux. This alternating flux is flowing towards the secondary winding. Now, so flux is linking with this winding, secondary winding. Here an EMF is induced in the secondary winding. EMF is induced in the secondary winding. How many turns are there? N2. Okay, so N2, and EMF is induced in the here. So see, we are applying voltage here, we are getting output as the voltage here. What is the common thing here? There is no voltage. V1 is equal to V2? No. I1 is equal to I2? No. But what is the common now? What is the common in between primary to secondary? Flux. Flux is common. Whatever the flux which is established in the primary winding going towards the secondary winding, so there is a common of flux. Flux is common in the circuit. Okay. Where it will flow? Where it will flow? In the cast iron. In the core, flux will flow. Okay, there is no connection. Now, how this E2 is inducing now? How E2 is inducing? Because of E1 only? Because of V1 only, E2 is inducing. So, that's why we are saying that it is a mutual induction. Mutual induction, not a direct induction, mutual induction. Because of the other voltage, E2 is inducing. So, because of the mutual induction, the E2 is inducing. So, that's why we can call it as, this one is mutual induction. E2 is established because of the principle of Faraday's laws of mutual induction. What is the meaning of mutual induction? It is not, E2 is not directly inducing. because of the E1, another circuit voltage. Yes, it is another circuit voltage. What is the common thing is here in secondary? Is E2 is equal to E1? No. Direct E1, I1 is equal to I2? No. Only the common thing is whatever the flux which is established because of the primary winding, which is going toward the secondary winding. So flux is common here. Because of the flux is flowing in this winding, an EMF is induced here. If you connect any circuit to here, if you connect these terminals to any load or anything, any circuit, anything, any equipment, then a current of I will flow, that is known as I2. Okay, so this is about working or principle of the transformer. Okay, right. Now you tell me what is the function of core. Now you tell me now what is the function of core. What is the function of core? What it is doing? What core is doing here? What core is doing here? Nothing doing? Huh? Is it walking? Is it stationary? Is it crying? Is it laughing? Then what it is doing? Core carries the flux. Yes, what it is doing? Core carries the flux. Where the flux is establishing? Flux is establishing in the core. What is the function? Why it is required? Why flux is required? Why flux is required? In order to induce an EMF. d pi by dt. d pi by dt. Okay. So this can be written in the basic formula as basic formula, not EMF equation, basic formula. Basic formula of this Faraday's laws of electromagnetic mutual induction is E is equal to N d pi by dt. It is the basic formula. EMF induced in the circuit is equal to the number of turns into alternating flux. This is the basic formula of the transformer, or you can say principle. What is the principle? Principle of Faraday's laws of electromagnetic induction, that is mutual induction is then that mutual induction formula. E is equal to N d pi by dt. For example, if you say it is a primary induced EMF, simply you write down E1 is equal to N1 d pi by dt. E2 N2 d pi by dt. Okay. E1 is equal to N1 d pi by dt. E2 is equal to N2 d pi by dt. Okay. So this is about principle and working of the transformer. Even construction also. Construction means simply how many parts you are having. You have to draw this diagram for construction of transformer. Okay, construction is different question. Principle and working is different question. Okay, construction is simple. So transformer consisting of mainly two parts. One is core, other one is winding. Core, what is the function of core? Core carries the magnetic flux. You have to draw this circuit. You have to represent every parameter V1, I1, okay, E1, V2, I2, E2, N1, N2. And windings. What is the function of winding? In the winding only EMF will be induced. Okay. In order to induce an EMF, what we require? Winding we require. If there is no winding, where will EMF will induce here? Okay. So E1, E2. So these both are E1 and E2 are not equal. What is the value of E1? Example. For example, you take what is E1? 230. What is E2? 9 volts. Okay. Sir, for both formulas, what are the different here? What are the different? For both formulas, different. What different are there? For both formulas. E1 is equal to N1 d pi by dt. E2 is equal to N2 d pi by dt. In both formulas, what are the different parameters you are having? Different compared to first equation, second equation. What are the different? Huh? Huh? Turns are different. A1, A2 is there. Okay, number of turns are different. Here N1 turns are there, N2 turns are there. Okay, so the value of induced EMF, I asked you at the starting of transformer, how the value of on what parameter the change of voltage is depends. Now we answer on what parameter change of voltage, change of level 230 voltage is changing to 9 voltage. On what parameter this change of voltage depends. Now you give answer. E value E1 is not equal to E2. How this E1, E2 are differentiating? In that formula, ma cheppandi, d pi by dt is equal, d pi by dt equal. Both formulas. Flux is same. Primary winding flux is same. Secondary winding flux is same. So E1, E2 on what parameter? Not equal. Equal, not equal. E1 is not equal to E2. On what parameter is depending now? Right side. Number of turns. So E1 is equal to N1 turns. E2 is equal to N2 turns. So the induced EMF is directly proportional to the number of turns. If more turns are there, more induced EMF. If more turns are there, more induced EMF. If less turns are there, less induced EMF. Now you tell me how we are getting 9 volts now. So for the secondary winding, we are having very few turns. For primary winding, for 230 voltage, we are having more turns. Okay, so the value of induced voltage in the primary as well as secondary depends upon the number of turns. If you wound the more turns, more induced EMF. If low turns, less induced EMF. So in order to get 1000 voltage, what you require now? Here you have to get more voltage, 1000 voltage. Here 230. What you require? You have to wound more turns. Okay. Okay. So here E is proportional to N. Okay. So that means whenever you require more induced EMF, you need to get more turns. Okay, right. Now E1 is less, E2 is more. That is N1 is less, N2 is more. What do you mean by N1? Number of primary turns. What do you mean by N2? Number of secondary turns. So this type of transformer is called step up transformer. Why? Because it is stepping up. 230 voltage is changing to 9 volts because of the turns. Okay, and second one is if E1 is greater than E2 or N1 is greater than N2, then this transformer is called step down transformer. So in the charger we are having step down transformer. Okay, input is 230, output is 9 volts. So E1 is greater than E2, step down transformer. Okay, right. Or you can say number of turns also. If number of turns are more in the primary, what is the meaning of 1 here? Primary. If number of turns are more in the primary than the secondary, then you can say step down transformer. If the number of turns are less when compared to secondary, then you can say step up transformer. Okay, right. Now we will derive the EMF equation of the transformer from the principle. Okay, right. Do you understand the principle? How it is EMF is inducing? How EMF is inducing? Can anyone answer? How is EMF is induced in the transformer? How the EMF is changing when compared to primary to secondary? How it is changing depending upon the number of turns. What is the common thing? Flux is common in the primary winding and the secondary winding. Okay, right. Flux is common in the primary and the secondary, but current is different, voltage is different. Okay, right. EMF equation of transformer. EMF equation of the transformer. Okay, right. So what is generally with respect to principle, E is equal to N d pi by dt, but here we have to get what is d pi. What is d pi? It has one value. What is dt? It has one value. So here our aim is to find out what is the value of d pi and what is the value of dt. That we have to find out. That means two parameters. Okay, right. So here kindly note down this one, derivation is important. I will give the notes, but if you write once, twice, you will get the answer. For any derivation, or construction or principle, you have to draw this diagram. Only one diagram. Okay. Transformer, it is in the square. So primary winding, we are applying AC voltage. Okay, AC current V1, I1, E1, it is induced EMF. Okay, flux is flowing as clockwise direction in the core. Two windings are available. This is a secondary winding, or we are connecting this secondary winding to the load. So here we are having secondary voltage, secondary current, secondary induced EMF. This is the diagram which is you can use for this one for explaining of working and principle of the transformer. Okay, and construction of the transformer and derivation of the EMF equation. Okay, for transformer means you have to draw this one. Okay, state and explain the principle of transformer, you have to draw and write down that principle of the transformer, how it works. Okay, construction, you have to draw what are the parts. Only two parts are there, you explain the two parts, it's working and it's manufacturing. Copper is, winding is made up of copper, core is made up of cast iron. Okay, and EMF equation also you have to draw. Okay, right. You draw this diagram, I will explain the derivation now. Draw this one. Once you draw, you will get practice. You will get practice. That's why you have to draw. You want fans? You want fans? There is there. That. So, this is about a main circuit diagram of the transformer. Okay. Now, so what is the principle? What is the principle of the transformer? Average induced EMF in the transformer is given by the formula A is equal to N d pi by dt. This is the general formula, average induced EMF. So, if it is a primary, then you modify the formula as, so E1 is equal to N1 d pi by dt. So, this is called primary induced EMF. Primary induced EMF. Okay? Primary induced EMF. Now, see, what is meant by dp? dt means difference of time. Difference of pi, difference of time. d pi is nothing but difference of pi, difference of time. Okay. So, we have to get these two values. What is d pi, what is dt? You have to get these two values. Okay. So, see, y-axis is pi, x-axis is time. How this pi is alternating 1. Alternating 1. Okay. Right. Okay. This total is time period t. Time period. How can you define time period? How can you define time period? How can you define time period? Huh? Define time period of the waveform. Huh? Time period of the waveform. Time taken to complete one cycle. Do you remember that? No? Time period is nothing but time taken to complete one cycle is known as time period. Okay. Now, dt is nothing but difference of time. d pi is nothing but difference of pi. So, pi value varies from 0 to maximum value. 0, negative maximum 0. Okay, now you got d pi is maximum to minimum is 0. Maximum to minimum 0. So this is happening in which time? This is pi m. We are getting maximum value 0 to pi m and 0, then negative maximum 0. What is the maximum value? D pi is we are getting maximum value at what time? At what time? We are getting this maximum value here at what time? At what time we are getting maximum value? Time. It is mentioned there. We are getting maximum value at what time? Huh? T? Okay, very good. So, we are getting here, so this is the total time period T. Here it is a T by 2. Here it is a T by 4. So, in the time of T is equal to T by 4, we are getting maximum flux. So here we require to find out d pi and dt. So d pi value is maximum flux, dt value is now how in which time we are getting this maximum flux? T by 4. Substitute in the formula. Substitute in the formula. Substitute in the formula. Here you will get. Can I erase? No. Can I add one more? Right. So here E1 is equal to N1 d pi by dt. Okay. So d pi is how much? Pi m. Okay. This pi m we are getting with respect to T by 4. Yes. So now substitute here. E1 is equal to N1 pi m by T by 4. Okay. Now this can be written as N1 pi m 4 by T. Okay. What is frequency? How can you define frequency? How can we define frequency? Time period is equal to 1 by f, or f is equal to 1 by t. Yes, inverse of time period is nothing but frequency. Okay, so here it is 1 by t, 1 by t. So replace this 1 by t with a f. So here n1 pi m 4 into f, E1. E1 is equal to N1 pi m 4 F. So what is the name of this one? E1? Average primary induced EMF. Average primary induced EMF, that is E1, is equal to how much? N1 pi m 4F. Okay, what is mean by F? Frequency of the supply. What is mean by pi m? Maximum flux available in the core. What is mean by N1? Number of turns in the primary. Okay, number of turns in the primary. Now over? No, derivation is not over. Is it over? What we have to get now? N1 is over, pi m is over, 4 is over, F is over. Why we require now? It is average primary induced EMF. You require which voltage? In AC, which voltage will consider? In AC, in alternating current, in sine wave, which parameter will take? How many values we are having for sine wave? How many values we are having for sine wave? Instantaneous value, maximum value, average value, RMS value. So which value you have to take from the sine wave? RMS value. Okay. So now Since f is equal to 1 by t, substitute here. Okay. Now, is there any relation between average value to RMS value for the sine wave? Is there any formula? Average value to the RMS value. Is there any formula is available? Huh? Form factor is equal to VRMS by V average. Did you study it for AC circuits? Form factor is the ratio of RMS to the average. And now average value is available. RMS value you have to get. So E1 RMS is equal to form factor into V average. That is nothing but here E1 average. That means, what is the form factor of the sine wave? What is the form factor of the sine wave? Value. Form factor of the sine wave value. You don't know? అన్నీ మర్చిపోతే ఎట్లమ్మా? For the sine wave, the value is 1.11. Okay, so now A1 RMS is equal to 1.11 into 4 into F into pi m into N1. So this finally you can write as, okay, V1 or E1 is equal to 4.44 F pi m N1, which is measured in volts, or secondary induced EMF V2 is equal to E2 is equal to 4.44 F pi m N2 volts. This is the EMF equation of the transformer. Primary induced voltage or secondary induced voltage. V1 is equal to 4.44 F pi m N1, or secondary induced EMF is 4.44 F pi m N2. Okay. So this is about the derivation of EMF equation of the transformer. Okay. The question is like this: derive the EMF equation of the transformer. Then you have to write down this thing. Derive the EMF equation of the transformer. You have to write down this one. Okay. Right. Did you note it down? We'll do the problems now with respect to transformer. We will do the problems now. Amma, write down. No need to disturb the class. Okay? Right, we will do the problem now. తొందర రాయండి, మరి టైం వేస్ట్ చేయొద్దు. అయిపోయిందా? అవ్వలేదంటే కష్టము. So here, after knowing the formula, what is that formula? EMF equation of the transformer is equal to V1 or E1 is equal to 4.44 F pi m and N1, or E2 or V2 is equal to is equal to 4.44 F pi m N2. Okay, after knowing this, you have to get two more formulas. That is, if you substitute here, E2 is why it is going now? Listen, after knowing the formula of E1 is equal to V1 is equal to 4.44 F pi m N1 and V2 is equal to E2, that is equal to 4.44 F pi m N2. Okay, so can you find out V2 by V1 or E2 by E1? What is the value? What is the value? 4.44 F pi m N2 by 4.44 F pi m N1. So this is get cancelled. What the value will get? Which is nothing but N2 by N1. Okay, that means V2 by V1 is equal to E2 by E1, that is equal to N2 by N1. Okay, E2 by E1 is equal to N2 by N1. So E1 is nothing but primary induced EMF, E2 is nothing but secondary induced EMF, N1 is primary number of turns, N2 is nothing but secondary induced EMF. Okay, right. And one more thing, in the transformer, input power is equal to P1, input power is equal to output power. Power will not change. Power will not change in the transformer. Power is equal. Input power is equal to output power. Okay, so that means what is the power formula? P1 is equal to P2. What is that? V1 I1 is equal to V2 I2. Okay, V2 I2. So can I get V2 by V1 here? I1 by I2. Okay, so here one more thing from this. Okay, one more formula. V2 by V1 is equal to E2 by E1 is equal to N2 by N1 is equal to I1 by I2. So this is called transformation ratio, generally which is represented as K. Transformation ratio is nothing but it is a ratio of voltages, it is a ratio of currents, it is a ratio of turns. Okay, V2 by V1 is equal to E2 by E1 is equal to N2 by N1 is equal to I1 by I2. Current only different, remaining all are same. 2 by 1, 2 by 1, 2 by 1. V2 by V1 is equal to E2 by E1 is equal to N2 by N1. But current is equal to I1 by I2. Among these all things, okay, if you know any 3, can you find out remaining 1? Yes? For example, you know V2 by V1 is equal to N2 by N1. V2 by V1. What is V2? Secondary voltage. What is V1? Primary voltage. Okay. You know secondary number of turns. You are unable to find out N1. So, by knowing the V2, V1 and N2, you are able to find out N1. If you know only one current, are you able to find out remaining current? I2? If you know I1, I2 can be obtained? Yes, I2 can be obtained. Okay. Right. So this is the formula, one more formula, that is V2 by V1 is equal to E2 by E1 is equal to 4.44 is equal to N2 by N1, that is equal to I2 by I1, that is equal to I1 by I2. I1 by I2, only current is different, I1 by I2. Remaining all are 2 by 1, 2 by 1, 2 by 1. Only current is 1 by 2. Okay. Now we will do the problems on the transformers. Okay. అవసరం లేదండి, అవసరం లేదు, నాట్ రిక్వైర్డ్. పల్లె అవసరం లేదు, రైట్ అండి. See here, write down this problem. So every parameter is available in the question. Okay, write down that parameter as the given data. For example, in the exam you are unable to remember the formula. What you have to do? At least you write down given data. You will get 1 or 2 marks. అర్థమైందా అండి? నాకు ఫార్ములా గుర్తులేదు, నేను రాయను అని అనకూడదు. రైట్ డౌన్ గివెన్ డేటా, విల్ గెట్ 2 మార్క్స్. అట్లీస్ట్ యూ విల్ గెట్ 2 మార్క్స్. ఓకే, సో ఏ 44 kVA ఇది పోయింది మళ్ళీ. A 44 kVA, that is power. Power is, okay, 44 kVA. This one is, first one is V1, second one is V2. First one is V1. This is power. This is V1. This is V2. Okay, frequency. Okay, 44 kVA, 1000 by 415 voltage. What do you mean by 1000? 1000 is equal to V1. 415 is equal to V2. Comma, 50 Hz single phase transformer has 88 turns in the primary or secondary? In the primary. That is N1. N1 is equal to 88. Write down what you want to find out. Find out number of turns in the secondary, that is N2 is equal to how much, and full load primary and secondary current, that is I1 and I2. I1 and I2. Then maximum value of the flux. Maximum value of the flux. Okay, that means pi m. Now write down the given data as a solution. Solution, write down the given data. P is given, that is you may write P1 or you may write P2. Why? Because in the transformer P1 is equal to P2. In the transformer P1 is equal to P2. Okay, right. Then V1 is given. V1 is how much? V1 1000, V2 415 voltage. Okay, F 50. Then number of turns in the primary, N1 88. From the knowing V1, V2 and N1, can you find out N2? Yes, N2 by N1 is equal to E2 by E1. Write down that formula, enough. N2 by N1 is equal to E2 by E1. N2 by N1 is equal to E2 by E1 or V2 by V1. Now, what is the given data? What is the given data? Given data P1 or P2 is equal to how much? How much? 44 kVA. Huh? How much power? 44. 44 into 10 to the power of 1000 VA. That is nothing but 44,000 volts, volt ampere power. Okay. Then V1 1000 volts, V2 415, frequency 50 hertz. Okay, and then N1 is given, N1 is 88. From this what we have to find out? First one N2 by N1 is equal to V2 by V1. Okay, you know V1, you know V2, you know V1, N1, substitute in the formula. So N2 is equal to V2 by V1 into N1. That is equal to 415 by 1000 into 88. How much you write down? 36 number of turns should be in the, okay, it cannot be in the decimal, equate to, okay, 36 point something. So 36 you take, or 37. You rounded off that number. Why? Because number of turns cannot be in decimal. Number of turns. You can wound 1 ton or you can wound 2 tons. You cannot wound 1.5 tons. Okay, right. Okay, right. 36 tons. Then next one. Next one in the question. Calculate primary and secondary currents. Yes. Next one is primary and secondary currents. So that is I1 is equal to how much? I2 is equal to how much? Okay. So here we know power, that is equal to 44,000 is equal to V1 I1. Okay. So here 44,000 is equal to V1 is how much? 1000 into I1. What is I1? 44,000 by 1000. How much now current? 44 amps. Okay. After knowing the value of I1, can you find out I2? I2 by I1 is equal to E2 by E1, V2 by V1, or N2 by N1 also, no need to worry. Okay. If you know one of the current, you are able to find out remaining current. I2 by I1 is equal to I2 by I1 is equal to V1 by V2. I2 by I1 is equal to V1 by V2. Okay, right. Then I1 is equal to 44. Okay. So after knowing I1, so I2 by I1 is equal to V2 by V1. You can use this formula, or you know the end to end V1 by V2. Okay, I2 by I1 is equal to V1 by V2, or you can use this formula also, N1 by N2. You know I2 by I1 is equal to V1. V1 is how much? 1000? 1000 only? 4000? 1000? Huh? 1000. Okay. V2 is 415. What you value you know? You know I1 value? So here from this I2 is equal to 1000 into 415 into 44. How much I2? 106 amps. Yes. So you obtain the value of number of turns, you obtain the I1 and I2. Then we require, after this third question, you require pi m. You require pi m? Yes? For this, you can use any one of the formula. V1 is equal to 4.44 F pi m N1. Okay. So here pi m is equal to V1 by 4.44. F is 50 into pi m is how much? Pi m. N1 is how much? N1. 88. Right. V1. V1 by 4.44 F N1. Okay, right. So pi m is equal to V1 is 1000 by 4.44 into F is 50 into N1. N1 is how much? 88. How much is the pi m now? 0.058 Webers. 518 0.0518 is the Webers. So you have to remember in the transformer two formulas. One is EMF equation formula, another one is K value, transformation ratio formula. That is V2 by V1 is equal to E2 by E1 is equal to I1 by I2 is equal to N2 by N1. Other one is EMF equation, either E1 either E2. E1 is equal to 4.44 F pi m N1, or E2 is equal to 4.44 F pi m N2. Okay. Write down the second problem. A single phase transformer has 660 turns on the primary and 92 turns in the secondary. If the primary is connected to 3600 voltage supply, calculate the secondary voltage. If the secondary current is 213, find the primary current. So I have drawn the general transformer connection, that is a transformer having the core and primary winding and secondary winding. In that okay, V1, I1, V2, I2 are there. We are finding one of the parameter by knowing the remaining parameter. What is meant by V2? Output voltage. What is meant by V1? Input voltage. What is meant by I1? Input current. What is meant by I2? Output current. Like that you are finding for the transformer. You are finding different parameters of the transformer. Okay. Primary turns are available, secondary turns are available. Okay. Then you need to find out the induced EMF E1. Okay. Among the all parameters you are finding the required parameter. Okay. That is our aim. For the given transformer, if you know V1, I1, N1, are you able to find out V2? Yes, you can find out. Okay? Right. Write down this one. Write down the given data for the given problem. Write down the given data. Write down that one. Given data you write down. For the single phase transformer has 600 turns on the primary, that is N1 is equal to, write down given data. After problem, write down given data. N1 is equal to 660. 92 turns in the secondary, N2 is equal to 92. Write down given data. Then if the primary is connected to 3600 voltage, V1 is equal to 3600. Calculate the secondary voltage. V2 is how much? N1, N2 you know? V1 you know? V2 you are able to find out. Yes, V2 by V1 is equal to N2 by N1. Simple. So everything is available in the question, but you have to remember the formula. That's all. You have to remember the formula, substitute in the formula. You will get direct questions. Okay? You have to remember the formula. That's all. You have to remember the formula. Okay, let's do this problem. What is given data? What is given data? Given data you tell me. N1 is given. N1 is how much? Huh? 660. N2? 992. V1 is given or V2 is given? V1 is given how much? 3600. This is volts. Then current is given. Any current? I2 is given. I2 is how much? 218 amps. Is there any data is missing? Given data you tell me. Only this much is given? Yes? Right. F is given. F is not given. Right. What we need to find out? First one is V2. Second one I1. Then the two only. Right. So here for V2, here I1. You have to find out. Okay. V2 by V1 is equal to N2 by N1. Okay. So here we need to find out V2. V2 is equal to N2 by N1 into V1. What is N2? 92 by N1 660 into V1 3600. So secondary voltage is how much? Primary voltage is given. You need to find out secondary voltage. Secondary voltage is given by 92 by 660 into 3600. 501 volts. Always for the parameter you write down the units. Don't forget to write down the units. Okay. Though this is first one. Okay. First step is you need to find out V2. So V2 is 501 volts. I1 also you are able to find out by knowing the N1, N2. Yes? Second one. I1 you need to find out. I1 by I2 is equal to N2 by N1. Yes? I1 by I2 is equal to N2 by N1. Same formula. Okay. I1 you need to find out. Okay. So I1 is equal to N2 by N1 into I2. So here, so I1 is N2 is how much? 92 by 620 into I2. I2 is how much? 280. I1 is 30 point something is there. So this is the way of solving the problem. Is it easy? Is it hard? Everything is available in the question. Everything is available in the question or not? Yes, everything is available in the question. Just you have to remember the formula and substitute in the formula. That's all. Okay? Right. So actually for the transformer construction, there is no need to draw this total thing. You seen this one in the colonies. So it is a distribution transformer. Okay, no need to draw this. Only this is enough. This transformer is housed in this tank. Generally this will not visible. You see this one terminals like this. Okay, no need to draw this one. No, not required. Okay. Okay. So transformer actually inserted in the tank. Okay. What are the applications of the transformer then? Where can you use the transformer? What are the applications of the transformer? Transformer can be used in the chargers. Transformer can be used in the rectifiers. Transformer can be used in the daily life, in the TVs. Transformers can be used in the system, your system, personal computer, in the laptop, smart board. Okay, wherever you require to change the level of voltages, transformer is required. That are the applications of the transformer. Okay. So in generating station also we'll use applications of the transformer. Okay. Applications of the transformer. In generating station we'll use. For the distribution also we'll use. Okay. So these are the different different applications of the transformer. Okay. In the cell phone also transformer is available. Okay. In the cell phone also, inside of the cell phone, mobile phone, transformer is available. Why we require transformer again then? Why we require transformer again in the mobile phone? Why it is required? Why? You are not answering now. Already you are charging with respect to 9 volts. Then again this mobile phone is having inside this transformer is available. Why it is required? I am asking. For the display. For the display 9 volts is not enough. 9 volts is not enough. So 9 volts DC is converted to 1000 or 500 or 300 DC voltage. For the display purpose we require transformer. Wherever you need to change the voltage, transformer is required. That is the application of the transformer. Okay? Right. So we'll study now. Amma, if you require 5 minutes of break, don't go out. If anybody require, you go one by one, not all together. 5 minutes break, only 5 minutes. Not all together. 2 members, 3 members, you go and then you return. 5 minutes. Remaining students keep here only. 5 minutes. Don't go all together. Only 2 members or 4 members. Okay? Only 2 members. So we left with we left with 2 topics. Huh? How many topics are there? Only first part is not over. What about the second part? Second part. measurements. So in this machines part we left with the induction motor and alternator. Okay, there is no problems in this both. I will explain that one. What is the principle? I will explain now. With this only we left with measurements. Okay, in the next week we will complete that measurements and we will complete third unit also. Hello, shall I start? Okay. So induction motor. Induction motor. Okay. So generally the other name of induction motor you can say it as rotating transformer. Other name of induction motor is rotating transformer. Okay. So rotating transformer means actually transformer. What is meant by transformer? Transformer is a static device. Transformer is a static device. Okay. Where EMF is induced because of the Faraday's laws of mutual induction. It is a static device. It cannot move. It cannot rotate. But the same principle, whatever the principle we are using for the transformer, same principle we are using for the induction motor. But here what we are doing, see, I will explain now. So induction motor. Okay. Okay. Write down the circle, actually I am not getting here. Otherwise, other wait. So instead of drawing total circle, I am drawing part of the induction motor, one part. Okay, it is upper part like this. Okay, so here this is called stator. Stator having stator slots. Okay, so in these slots we will keep the conductors. Okay. So here also in these slots we will keep the conductors. Okay, so this is rotor slots. Okay, in both rotor and stator has slots and has conductors. Okay, so this is three-phase induction motor principle. Three-phase induction motor principle. See, so induction motor, I think you know the DC generator. DC generator is having stator as well as rotor. So in stator, field is available. In the DC generator, in the stator, field is available. But here we cannot use field. Okay. So here induction motor, one is having stator, other one is rotor. Two parts are available. One is stator. Okay, stationary part of the induction motor is called stator. Rotating part of the induction motor is called rotor. Okay, so here both are same slots. Okay, rotor is having the slots where we will keep the conductors, and rotor is having the slots where we will keep the conductors. Okay, it may be here also. Okay, you can use either of one, no need to worry. You can use here conductors, here either of one. Okay, so here rotor is having rotor conductors, starter is having starter conductors. So this stator is connected to three-phase supply. Three-phase AC supply. Induction motor is a AC machine. Okay, three-phase AC supply. So I said the principle we are using for the transformer is equal to the principle for the induction motor. Why? Because the other name of rotating transformer. Okay, now so here see rotor is like this. Rotor, stator, induction motor. Okay, so here we are having the slots here, slots and conductors like this. Okay, and rotor is having slots and conductors. Okay, here there is no field here. There is no field. Okay, when compared to DC generator, there we are having field north pole, south pole, and we are rotating the conductor in the DC generator or in the DC motor. Okay, a current carrying conductor placed in the field, it is rotating. Okay, keep it aside. It is not worked with the AC machines. So AC machines consisting of, okay, One is induction motor, another one is alternator. Okay. So now see here, induction motor. Induction motor consisting of two parts. One is outermost is starter, it having slots and conductors. Rotor also having the slots, it is also having the slots. There is no field winding, there is no field, north pole, south pole not required now. Okay, only slots. Both stator as well as rotor is having the slots. Okay. Now, what is the principle behind this? Same principle. E is equal to d pi by bt. But here there is no turns. Here there is no turns here. Generally, induction motor is n d pi by dt. Yes? E is equal to n d pi by dt. That is the principle of a transformer. Or E is equal to d pi by dt. Generally. So here you may say n is equal to 1 also. No need to worry for that. For the induction motor, okay, flux linking with the coil is changing with respect to time. D pi by dt. What is the meaning of pi is changing with respect to time? Okay, flux linking with the coil changing with respect to time. That is d pi by dt. And EMF is induced. And EMF is induced. That is the concept actually. Okay. Flux linking with the coil is changing and EMF is established. Flux linking with the coil, that is d pi, is changing with respect to pi is changing with respect to time. And EMF is induced in the winding or conductor. That is the principle. Induction principle. That is Faraday's laws of electromagnetic induction. With respect to transformer, it holds good for induction motor. But here, there we are having primary winding and secondary winding. Here also you can say starter slots is having starter conductors. You can say it is a primary winding. No need to worry. It is a primary winding. Rotor also you can say it is a secondary winding. Okay, but here, okay, here the winding is then a conductors are there. So conductors, starting terminal. For example, you say starting terminal. Starting terminal we are keeping in the slots like this starter, like this and ends. It is short circuited. Okay, where it is starting, here we are keeping like this. In the slots, conductor, continuity supply, continuity copper wire here available. That means short circuited. Okay. Rotor conductors, short circuited, or you can say they are in closed condition. Before explaining about the working of this induction motor, how it is rotating. Induction motor means it is an induction motor. I said whenever I am giving the supply, it is starting rotating. Here there is no poles. It is AC machine, AC motor it is. There is no poles, only DC only you are having poles. Okay, DC motor. Okay, one is stationary part, other one is rotating part. Okay, right. Now what happens? Here the winding is there, conductors are short circuited, and here also conductors are available. It is a three-phase connection. Output, this one is three-phase connection, and there are three terminals coming out of this. Three terminals, 1, 2, 3. Three terminals are coming out of this. Three-phase means three, RYB, red, yellow, black, or red, yellow, blue. Okay, I think you have seen that three colors, red, yellow, black, or red, yellow, blue. Three phase. So the three wires are connected across in the stator winding, stator slots. Okay, I have applied, it's a motor. So I have to apply the voltage. So I am applying the voltage. Okay, You understand now? This it is a stator, rotor. Stator is having winding. So I am connecting this one to with respect to voltage. 3-phase voltage. 3-phase voltage. Okay. So why? Because it is a motor, induction motor. Motor is nothing but electrical to mechanical. Have to give the supply. So whenever I am giving the supply, a current of I is flowing through the winding of the stator conductors. Here current is available in the all the winding, all the conductors, current is available. Okay. So these conductors is okay because of they are wounding on the cast iron. Wounding on the cast iron. Okay. So here see, for the transformer what happens actually? For the transformer I am giving the supply, what happens? AC supply, what happens? AC supply, AC current wounding and a flux is established. Okay. In the same way, because of the woundness of these conductors which are in stationary, okay, an EMF induced in this rotor stator conductors. Okay, an EMF that, okay, what is that? Okay, flux is established in the stator conductors. Simple. I am applying the supply to the stator. What happens? Because of the woundness, stator conductors, okay, iron piece is there, cast iron. In that cast iron, a magnetic field established. Magnetic field. So magnetic field means flux is established. Okay, that magnetic field is called rotating magnetic field. Okay, so here there is a magnetic field now. Magnetic field. Because of the current available in the stator conductors. Okay, whenever we are giving supply, AC supply to the stationary conductors of the stator of induction motor, okay, a flux will be established in the stator conductors. Okay, these stator conductors flux will rotate around the stator. Here the flux is there, flux is there, flux is there. Total. Why? Because they are circle in nature. So stator flux, stator flux. So this flux will rotate. That's why we'll call it as rotating magnetic field. So this field is reacts with the stator conductor. See, stator is there, here rotor is there. This flux is react with the rotor conductors. Rotor conductors. Okay. Now rotor conductors. So here magnetic field is there. Rotor conductors are there. So here also, okay, flux is established. So here also there is a establishment of both fluxes. One is called stator flux, other one is called rotor flux. So because of the both flux,
ఇప్పుడు వీళ్ళని పంపించాలి సార్ మళ్ళీ 12:45కి థర్డ్ ఇయర్స్కి ఫోర్త్ ఇయర్స్కి లంచ్ ఉంటుంది అప్పుడు క్రౌడ్ అయిపోతుంది మళ్ళీ వీళ్ళకి
పంపిస్తా. టైం అయిపోయిందా?
12 అయిపోయింది.
ఓకే, పంపిస్తా. అమ్మా లిజన్ you have to go. Just I will complete this, will go. Okay, we will continue in the next class. No need to worry. Afternoon other students. Okay, we will continue in the next class. Over, this is over. Just wait, just 1 minute. Okay, So because of the magnetic field established in the stator and magnetic field established in the rotor, they will interact with each other, and this rotor will start rotating. Rotor will start rotating because of the magnetic field established in the stator as well as rotor. Then rotor will start rotating. Okay, what is the speed of this? What is the speed? That speed is called synchronous speed, is given by 120 F by P. 120 F by P. Okay, right. So we'll continue in the next class. Okay, Amma, listen, if anybody require notes, I will share. Okay, one of your student is taken, but if you are anybody need, okay, I will share the notes. Okay, we'll meet in maybe next Saturday or next Saturday. Okay, right. Thank you. Right.